Good morning and welcome to the 2021 Asphalt Conference virtually. So nice to have everybody join us today. It's been a long year with COVID. We're glad that's getting over. Hopefully this is going to be the last time we have to meet virtually. But the good thing is we all learned new words like Zoom and social distancing, and hopefully that'll be in the past. But thank you guys again. My name is Terry Meyer. I'm the president of Team Lab. I'm honored that Dale had asked me to be a moderator this morning, so thank you very much, Dale. It's an honor to be able to help you out today. We have over 300 participants joining today, from contractors to suppliers to the North Dakota DOT, North Dakota LTAP people. We have local government, city engineers, city maintenance people, county highway departments. We have consulting engineers. We have UND research people joining us, as long as students from our local colleges. It's amazing how when a good group of people like this gets together, we can all get better as a team. They always say team, together each achieves more. That's what this whole system is about. Everybody working together and everybody helping one another. The committee has put together many hours and they have got together a top-notch agenda that also has top-notch presenters. So I'd like to thank the committee personally by your endless hours behind the scenes that nobody really gets to see, all the stuff that you guys do behind the scenes. That to me is more important than us just putting on a presentation. It's what you guys do behind the scenes that makes all this mesh well and together. So thank you very much. Also, all the people on the committee subcommittees, your help is also very important, as well as their secretaries and people. So just thanking everybody from the top to the bottom, from the bottom of our heart, is huge to all of us. Thank you. We're also very lucky to have Mr. Asphalt, the king of asphalt, the king of hot mix, Ken Swendine with us. So Ken, welcome. Thank you very much. Thank you, North Dakota Asphalt Paving Association, for providing us Ken for this, and we will learn from Ken. And Ken, hopefully you can learn from all of our presenters as well today. The event is going to be recorded, and it's also going to be posted on the LTAP website. As long as the presentations. So once everything's done, you can go to the LTAP website and then find anything out that you might have missed, or you can go back and research it. And that the availability is always going to be there to continue your education behind the presentations today and tomorrow. So it's very nice that. And then also after each presentation goes, there's going to be a short, as always, question and answer session. We'll try to keep it short, because there again, we want to keep on track with everything. They've put together a very time-sensitive agenda, so hopefully we follow that. But also, we want you to ask your questions, because it's asking questions which everybody learns about. So if we're not asking questions, we're not all learning together. So just remember that. Don't be shy. You're not in an audience of 300 people. You're sitting behind your desk right now, so you can ask that question. We need that. So it's very good to have that relationship with the DOT. Without the DOT, the North Dakota DOT, we would not be successful as a group, being the contractors, the engineers, everybody else as a group, like I said earlier, meshes together, so it's the relationship with the North Dakota DOT that puts us all together, and there again, makes a great team. So it's all about teamwork, like I said. And so thank you, North Dakota DOT, for all you do for the states, the counties, the municipalities, the townships. You're the top. You're what we look up to, and we appreciate all you do for everybody involved in our industry. So thank you very much. So with that said, it is my pleasure to introduce the new North Dakota Director of Transportation, Bill Panos. I'm going to give a little bio about Bill. Governor Doug Burgum appointed Bill Panos to lead the North Dakota Department of Transportation in August of 2019. Panos served on the board of directors for the American Association of State Highway and Transportation Officials. In addition, he serves as vice president of the Western Association of State Highway and Transportation Officials. That represents 18 DOTs. So as you can see, just from that, Bill is very, very, very qualified to lead the North Dakota DOT the next level. So thank you once again, Bill. Bill, working together, national issues that support efficient and effective transportation systems. Bill previously served as the director of the Wyoming Department of Transportation from 2015 to 2019. Great job, Governor Burgum, to steal him away from Wyoming. Bill, I hope you like the North Dakota love. Bill was also the director of the Department of School Facilities from 2013 to 2015. And prior to moving to Wyoming, he had 37 years experience in leading the private and public sector organizations. So with that said, Bill, congratulations on your position. We welcome you. Thank you.
Terry, thank you. And thank you for all of you for taking the time to be here. You know, as Terry was pointing out, partnerships are the key to our work, and we are grateful for each and every one of them. So many NDDOT partners are here today. Contractors, suppliers, the Upper Great Plains Transportation Institute, all of our team NDDOT members, consulting engineers, University of North Dakota research folks, and many, many, many more. Together, all of us, we all do better together. Innovation is, as you know, the key to advancing our mission. And to do that, we must be willing to fail, learn, and then try again. An example is the Minnesota Imminent Road program. The Imminent Road is a pavement test track made up of various materials and pavement owned and operated by the the Minnesota DOT. And NDDOT and Upper Great Plains Transportation Institute are partners with Minnesota in this project. The research track explores ways to make roads that last longer, perform better, cost less to build and maintain, be built faster, and have a minimal impact on the environment. Research collected at the Imminent Road program has been used to save millions of dollars and generate innovative methods that will be used in the future. And, you know, being innovative isn't just about test tracks and test roads like that which we partner with our friends in Minnesota on. It's also about things like autonomous truck and autonomous vehicle programs, smart infrastructure programs, intelligent transportation systems, the future of electric power for both trucks and for vehicles. These are all things that we here in North Dakota, and we as Western states, and we as DOTs across the country are working on every day. Investing in yourself is also advancing great work. Boots on the Ground is a new NDDOT ND-LTAP program that will greatly help by improving in-person technical assistance, and watch for more information about that in the next few days. This is these kinds of programs are not only a great opportunity to learn more, but it's a great way to build individual skills and invest in workers who are the key to our mission success. In North Dakota, our infrastructure investment is significant. And I want to thank you to all of the people on the call, all of the people around the state who build and maintain that investment. There's going to be some awards over the next day or two, and we have a lot to celebrate. The Perpetual Pavement Award. This was a project we did on Highway 5 in Pembina County. You'll be learning all about the Perpetual Pavement Award later today, but it's a big honor and a big thank you to the NDDOT team members who make awards like this possible for our state. And it's a remarkable group of people that we have in NDDOT and in our partner organizations, and they do a remarkable job every day. And these awards are much deserved and well deserved by all of the team members because they work so well together. Learn, evolve, implement, succeed. The conference themes provide the perfect recipe for a stronger North Dakota. Now, construction season is upon us, so continue to make safety the priority this season and be safe out there. And I want to thank you personally for all that each of you do to move the transportation mission forward in North Dakota and in this region. And again, on behalf of Governor Burgum, Lieutenant Governor Sanford, and all of the members of NDDOT, thank you. Thank you for all that you do. Let me turn it back to Terry.
Well, thank you very much, Bill. I tell you what, we cannot there again thank you enough for being our new leader of the North Dakota DOT. It's nice to have somebody with your experience. And there again, once people with your experience, it gives everybody else, us goals to achieve to get to, to your knowledge and everything that you've learned over the years, so thank you once again. Very great presentation. Now what I'm going to do is I'm going to step into the next presenter, and obviously everybody knows this presenter. It's my pleasure to introduce Dale Heglund. Dale is going to be going over the conference theme this year, and he's going to go over learn, evolve, implement, and succeed. Everybody knows Dale. Dale is the director of the North Dakota LTAP, part of the Upper Great Plains Transportation Institute at NDSU. Dale says he's grateful for the opportunity to share experiences from his past 40 years. Dale, I don't know where you get 40 years. You look like you're about 37. So I need some of those tricks. So, he wants to teach people to keep learning and getting educated instead of having somebody level out. He wants them to continue their learning process. So that's one thing I've noticed about Dale. I've known Dale in the industry for many years, and Dale is a huge asset to the state of North Dakota as well. So Dale, thank you very much. And you all know how passionate Dale is about his career. So with that said, I'm going to transfer over to Dale Heglund now. So Dale, go ahead. Thank you very much for all you do. It's appreciated to work with you.
Wow, thank you, Terry. That was very, very nice. And Director Panos, what a wonderful way to kick this off. If I could, we're very, very grateful. Dustin Ulmer is in the background running the whole conference for us. Dustin, great big thank you on behalf of the entire group here today. Thank you very much. And I'm hoping you can see my presentation, Terry, and my sound is good. And if it is, I'll continue. All right. So the theme, if you recall back if you were around, if you were part of the event, in 2019, we had Learn, Evolve, and Implement, and that's a pretty cool theme. And then the team got together, and there were a couple on our Michael Mart and Tim Horner that said, hey, let's ratchet it up a notch for this event and add succeed. Success is what the director is encouraging us to pursue. Success at the next level of learning. So today, tomorrow, let's pick up some nuggets of knowledge, put those into action, and figure out how to succeed. Succeed individually, succeed as companies, succeed as the greater good, that partnership that the director so wisely put together. If today is your first time with us, first time at the Asphalt Conference, thank you very much for joining us. There is so much to share. I can tell you that the steering committee struggled to figure out what we could move forward with because there is so much that our King of Asphalt, Ken Swedin, and the rest of the steering committee have to offer. So I hope you pick up a lot. I hope that you reach out to the experts that are in the construction industry, that are at the DOT, that are in our LTAP group, and ask for more information. If you ask, we're certain to help you. And also a great big thank you to the universities, North Dakota, University of Mary, NDSU, BSC, all the university students that are with us today. A big shout out to the paving class at NDSU and to UND for our senior project team. Thank you for joining. Keep learning. And what are opportunities? Where can you learn? The Asphalt Conference is one of them. We hope that you tap in LTAP. No matter where your career takes us, students, wherever you head in the transportation world, tap into us. We want to be that espresso of learning, that kick of caffeine, that boost of energy to really, really ramp it up a lot and to grow to our potential so that we have a better, stronger state. Because that's what the transportation's for. It's a business growth opportunity, and there's lots of learning avenues that we can help you with. And who else can help? Well, and Ken Swedin. One of his tips is Road Resource online. There are phenomenal tools that are free that partner agencies, organizations have put together. Today, we'll learn how to use some of those. Another, my favorite, is to tap into an expert. Here I'm with friend Tom Wood with Aztec. Tap into those people that make it look easy. The contractors that are just going down the road and they always get a smooth ride. How does that paver operator do it? What are they doing differently? Tap into them. Ask. Follow them. And really, I really want to focus on the contracting end. Contracting in North Dakota, second to none in the nation. As a matter of fact, we have proof of that because North Dakota AGC received the Small Chapter of the Year award. In North Dakota, our exceptional contracting force, #1 in the nation. I mean, a virtual applause, scream, yell, whatever you can do, please do that. You know, in learning and mentorship, I think of my career, and I think back to, boy, those learning moments that you don't even know you're being mentored. One of my favorite recollections, 1989, Tim Mayo, I'm in Park River, and we're just starting some of the flow meter calibrations and stuff. And he said, you know, I'm going to show you how to run the plant. I'm going to show you how to do other stuff. And quickly you learn that our contracting industry is not only there to help us learn, they are so knowledgeable. They want to provide a good product. They want all of us to partner together, as the director said, and create a better North Dakota. Other contractors, there are, oh my goodness, hundreds, thousands that I've reached out to. Brad Ballweber with Northern Improvement, partnering. The things that you can learn through informal mentoring programs, just by reaching out to those experts that make it look easy, will jump your career up. Asphalt Conference is one of them, Mentors another. The strength in our agency, in our industry. Here's a good article that was done for the women that are paving the way in construction in North Dakota. And you see Carrie and Molly and Sally and Nancy, phenomenal leaders in the construction industry. And this points out so clearly that leaders are among us. We need to tap into everyone, and diversity is our strength. Congratulations for putting this article out. It's such a powerful message. Diversity is our strength. It is our future. Embrace it, tap into it. And then during our learning in the next day and a half, we're going to talk old school. Here, Playsteads going up to the North Pole, little 12 horsepower skidoo. Can you imagine? And just like that snowmobile, we have paving techniques that are maybe outdated, that we don't think we should continue. We're going to share some things today that get us back to those old practices, that some things work now. We have different oils, we have polymers and such. And then we're going to go all the way from old school to what's new and latest. And as the director mentioned, MinRoads, the NRRA, phenomenal research facility that we get to be part of. Our boots on the ground unveiling, oh my. We've got 3 experts, Gerard in the upper left, Rodney in the center bottom, and Tom on the right-hand side. And that boots on the ground is our effort to recognize that the people on the ground are the ones making it happen, the contractors, the people taking the risk that are going out, understanding plans that may not be all that clear, that have some gaps, filling those gaps, figuring out how to make a quality product on the road. But our boots on the ground is more than that. It's reaching down to the people that are running the equipment, that are doing some of the planning, and it's connecting people. In this photo, we've got the city of Mandan, Public Works, Engineering, Morton County coming together. And you know what happens when you bring people together? Here's Michael Mart in the center. He's one of our steering committee members, engineering in Bismarck, the city of Bismarck, and he's with Public Works and another engineering teammate. And when you bring people together, we get past COVID, we can solve problems quickly. We can build those relationships quickly. We can learn. So just remember, even though we're still struggling at the tail end of COVID, pick up the phone, try to reach out, wear the mask, be respectful, but connections face to face is everything. We're going to go back to basics in some of the training that you'll hear. Back to the basics starts with asphalt paving. #1, crack sealing. And Tom Wood has my favorite quote of all times. I'll share what the public sees. In our roadway network, all they see are potholes. That's all we see in the comics. That's all we hear about in rating systems, right? We've got a wonderful network. We're not just patching. We're not just throwing a little patch over and calling it good. Our roadways look like this. Our contracting agencies are doing an exceptional job. We had a photo contest for last conference, and congratulations to our winners. So thankful that you took the pictures, you turned them in, and are letting us use them. Here are some from Shane and Candace and Chad and Brian and John. Thank you very much. Photos that are just beautiful, that really depict what our roadway network in the state looks like. It's amazing. Then a reminder that our photo contest starts now for 2020. So please take photos this year. The orange signs are just starting to get out. Take photos, turn them in. We want to highlight your work, your photography, your project. And then a safety message. The director talked about safety being the top item to look at. Here we see a David Lim and his Dunn County safety message or encouragement to really get to that vision zero, the DOT's vision zero, where everybody makes it home. My favorite quote from friend John is that, see something, say something. If we see a teammate that might be in trouble or someone on another crew, stop by, help them, make sure they're safe, that they go home. Because our work zones, wow, they're nothing short of war zones. The cars are projectiles coming within feet of us. Take care of your teammates. Make sure that we get home. We have celebrations to do today. We've got awards to recognize exceptional work at all levels. And all of this is possible because of our sponsors. Today's event, tomorrow's event is free. It's free because our supporters care. And our supporters are broad. Our supporters, our foundational supporters for our program lie within the state, our AGC, Federal Highway, the North Dakota DOT, and DAPA, putting this event on, helping us all learn. Knowledge is power, and let's multiply that knowledge through the cumulative efforts of all of us, with the end goal, again, where we started, to succeed individually, as a company, as a state, a better North Dakota. With that, Terry, I'll turn it back to you.
Thank you, Dale. I tell you what, everybody just see the passion that Dale has about his position? If everybody can take a little bit of that energy and just keep continuing that, and then like Dale mentioned earlier, a couple years ago, learn, evolve, and implement, and then to add that last word, succeed. If we can all just grab some of that, tap into that knowledge that Dale just expressed, the wealth of information out there for everybody is out there. So let's keep acting as a team, and then just keep continuing to go forward and forward and forward. And together we can keep solving everybody's problems. And that's why I love these models that they go after, the learn, evolve, implement, and succeed. They're just, what everybody is all about. So with that said, now, thank you very much, Dale. We appreciate your passion. We couldn't be going this way in the future without your leadership. So thank you very much. Now it's a pleasure for me to introduce the next speaker. From the great state of Nebraska, we have Robert Ray. Robert currently works for the Nebraska Department of Transportation as a flexible pavement and quality assurance engineer. He is a University of Nebraska Lincoln graduate. He has focused much of his last 15 years of areas of research and design of asphalt pavement mixes with high RAP contents and recycling agents containing rejuvenators, softeners, antioxidants to promote extreme long-term aging resistance. He has served on many NCHRP technical panels. What Robert's going to talk about, it's something that we've all seen driving down the highways over and over and over for years and years and years. Those big black mounds of old RAP material. Well, Robert has done a lot of research, and he's going to teach us how the RAP industry has learned, evolved, implemented, and also is succeeding. So with that said, we got a lot of, with Robert's presentation, I do believe that we're going to have some good questions and answers time afterwards. So this is a huge part of the advancements with the RAP material. So with that said, Robert, I'm going to pass it over to you, and you can educate us and teach us about the successes, what we can learn about RAP. Thank you for having us. Thank you for being here, Robert.
Okay, good morning. Thank you, Terry. And thanks to North Dakota DOT folks and Dale for inviting me to come and present for you. I'm Bob Ray from Materials and Research at Nebraska DOT. I head up the Quality Assurance and Flexible Pavement section. Let me get this presentation going. Okay. So today I'm going to talk about really the road that we've went on as far as getting wrap in our mixes and increasing our wrap amounts. And so first I'm going to start with a little background, give you a little bit of history, talk about a number of years ago, and then after that fluff, we'll get to more of the meat and potatoes of wrap and kind of the stuff that we're doing here. So real quickly, as you may know, we're in Nebraska, we have 93 counties. We have just under 2 million people. We have almost 7 million head of cattle at any one time. And we have 77,000 square miles of land. And we have about 10,000 miles of NDOT roadways, which we have about 85% of them are asphalt and 15% of them are concrete. So first we're going to go take a little trip back in time here, and then we'll work our way up to 2020. So we're going to go all the way back to 98, and then I'm going to jump into 2008, and actually I'm going to go all the way back to 1988. So I'll go in kind of some about 10-year increments real quickly, and then like I said, I'll get to what I would call the good stuff. So from 1988 to 1988 or 1998, Nebraska experienced a lot of truck increases, high tire pressure for fuel mileage. A lot of us refer to those as steel wheels. And in about 1993, we started implementing these mixes that had higher asphalt contents, and we really didn't have a lot of modified binders, so a lot of these were straight run binders. The mixes also back then had fairly low angularity. They had low dust content, at least here for us, and they were what I would describe as more of a sandy Marshall mix. And they tended to be on this, the fine side of the grading band. And what did we run into? We ran into a lot of permanent deformation issues with rutting. So that's kind of the 10-year span, 88 to 98. So now we're going to take 98 to 2008 and talk a little bit about what went on there. Polymer use started to get much more popular. Polymers were much more available. So we started using much more polymer modified binders. We also went to higher angularity, highly crushed aggregates, and we had some good dust, some man sand dust that we were adding into these mixes. And essentially we were able to minimize our natural sand content. And our mixes also got a little bit more coarse. So now we'll talk about, this is probably the most critical period here, is 2008 to 2020 or 2021, and that is basically the last 12 years. Basically, in 2008, some of you may remember when we went into some polymer shortages everywhere. In fact, there were some jobs they were not sure they were even going to be able to finish, and quite frankly, our binder prices went from about $300 a liquid ton. We had some that I actually bid for the city of Lincoln that were $950 a liquid ton in 2008. So we started looking at, first, how can we even get all these other jobs built? And so we focused more on wrap. It wasn't new to us. We were already using some wrap, but we looked at focusing on putting it deliberately in the mixes and still trying to maintain really good quality. And so one of the things that we had to focus on was going from what would be our standard oil, a 64, PG 64 minus 22. We looked at going at PG 64 minus 34s to bring in the softness and those low temperature characteristics to try to mitigate cracking in the mixes because of the stiffness of the binder. And so we created this whole list of mixes here, none of them that you would recognize. So the other thing that we had was, as Terry said, I'm glad to hear that you've experienced this too, we had milling stockpiles everywhere. In fact, I would estimate probably as many as 75 mountains, and we don't have mountains in Nebraska, but we did back then. And a lot of people actually referred to them as mountains and millings here, the Black Mountains. And basically, we couldn't even give this stuff away. I mean, so we had this abundance of wrap. So what happened? This is a little bit of a busy graph, but it kind of shows what happened between 2007, 2009. What happened in 2008? So we went from averaging about 7% wrap across all of our mixes, averaging 7, and then we jumped to 27.3 as an average. And how we got that was the industry was not motivated to put wrap in the mix because we paid the oil separately. And so what we did is we shared. We said if you use the wrap, every bit of oil savings, if we own it, in other words, we mill the road right there and we're going to lay it back, put it right back in the plant, we'll give you 15% of the savings, and the state, Nebraska DOT, got 85% of the savings. And that's what created this huge jump in the wrap use, because they had certainly motivation to use it. And I'm not sure if you pay wrap or oil separately or not, but you have to consider that. If you pay it subsidiary, there's another thing that we'll need to talk about later. But this just shows you a graph now of the red line is 2008 on the left there. And it just shows you how the wrap use went up. And right now, basically our average content is 39%. We have some mixes that run top end of 35. We've got mixes that run for the most part 50. We even have some mixes that were running at 65% wrap. But you can see here's a series of basically 4 years from 09 to 12 that we got better and better with the mixes and optimizing the design. Not a lot changed from there. It just took a little bit of time for the industry to really perfect these mixes and keep getting innovative. And I'll talk about some of the stuff that they did. So in a nutshell, over the last 12 years, we've used 9.2 million tons of aggregate. And to give you an idea, yeah, I had to throw some big red stuff in there, even though we're having some trials right now and tribulations, but we'll come back. Anyhow, if you were to stack it in the middle of the field, the pile of millings that we'd have now would be basically 7 miles tall. In other words, a binder, we've utilized or recycled 498,000 tons of binder, and that would be equivalent of refining 93 million barrels of raw crude to get that binder. Give you another idea of what that is these are what I had to look it up. It's called an Aframax cargo oil ship, basically. Good thing it wasn't in the Suez Canal, but basically in the last 12 years, we have saved 124 of these ships full of crude so far. And this is always gets some interest. In the last 12 years since we started doing this, we've saved about 458 million in binder and aggregate. And so every year we save about 30 to 40 million in just recycling this and get them back into the mix. So this is the question everybody asks me. That's great, Bob. That's great. How does it work? Well, this is what's called the Nebraska Serviceability Index. This is in our annual report. We print it out every year. And the Nebraska Serviceability Index is like the present Serviceability Index for all of the pavement designers. And what it does is it rates the road based on cracking and rutting, and then the IRI, or the smoothness. Those are the values that go into rating the roadway. And this, you can see the top line's the interstate and the bottom line are the non-interstate sections. And this graph, I just pulled it from the annual report. This starts in 2010. Remember, we started in 2008. And the main thing is, I would say as long as we're doing as good as we had been doing with that much recycle in there, we'd be doing good. But you can see, generally the trend is slightly improved, so that's a good sign. But let's just say hey, as long as it stayed the same and we're able to save that money and do the recycle, that's a win. That would be a success. So another thing, I'm almost done with the fluff. So this is kind of cool though, the post-consumer content label. This is what we started. Oops, sorry about that. This is what we started doing then. You can see on the right here, we created this badge to put on our plan. So we started using it in 2014. We put it in our annual report and we put it in our plan sets. And I'll show you a little bit bigger photo of it. And what it does is it shows NDOT's and the industry's commitment to recycling and our commitment to environmental stewardship. And it basically is based on the quantities of each project, or at the end of the year, the accumulation of all the material that we recycled based on average contents for the year. And so here's a little bit bigger picture. It's a good thing. This is actually last year, it would be 2019's recycled. And basically you can see on the top is the raw materials, 4.3 million tons of raw materials. And it talks about the post-consumer recycled content, 1.5 million. It gives you the average recycled content and then the estimated value. So in 2019, the total with crushed concrete and asphalt, we saved about 60 million in recycling. Here's just a copy of the front sheet of a plan set. On the bottom left, this is the Burwell West project. You can see, I know it's hard for you to see, but the bottom line on this one project, the savings on this was an asphalt overlay job. This one job was $684,000 in savings with the recycle on the single job. So every plan set gets this badge or this post-consumer content badge. Pretty neat, a good measure of environmental stewardship. So, okay, as I promised, I'm gonna give you get to the meat and potatoes of what we do here. So the first thing, so how did we get here? Well, you know the story. We started in 2008 with binder shortages and whatnot. Wrap use was not new, but we now focused on how can we optimize the wrap. So I'm going to talk a little bit about mix design changes, what we had to go through, and then talk about the plant modifications that were necessary. So how did we get there? The mix design changes. First one, as I said in the earlier slide, softer binders. And what well, I'm going to talk about that in the next slide here. We adjusted our air voids at end design. We also looked at VMA allowances. I'll talk about that in some more detail. And obviously we have to address both of those volumetrics due to the dust that gets introduced into the system, or this minus number 200 material. So let's talk a little bit about the binders first. The first thing we did. So basically the wrap, we did many extractions and graded out wrap binders. And in general, a general statement would be most wrap is going to grade out about a PG 80 something and a minus 16. So you can see the low end temperature of minus 16 degrees Celsius is not very good over time. It's oxidizing, it's getting stiff, but in general, it's basically an 80 something minus 16. So the high temp we're not so worried about because we've got very high stiff binder in there. So we're not going to run into rutting issues, obviously, but we need to focus on the low end temperature to correct this blend of what we have out in the field. And so how we tried to repair it the best we can, and we have another presentation I can do. We're working on rejuvenators and recycling agents, but at the time, the best thing we can do is get very low temperature soft grade binders. In other words, minus 34 grade binders. So right now what we use, and I'm going to talk not about MSCR, I'm just going to talk about the last system in the performance graded binders. We use all 58 minus 34s and 64 minus 34s. Very good base XX minus 34 oil. It's XX because they won't grade out the top end, and they bring in polymer to bring in the top end temperature to reach that 58 and the 64. Typically, the binder, this XX minus 34, roughly is about a PG 49, about minus 37. And so the last one, so I want to note this so you're aware of it too. We use warm mix additives in all of our mixes at a rate of 0.7%, and not to be running it late in the year or in the middle of summer and running the mix at 200 degrees or 250. We primarily use warm mix additives as a compaction aid. So I don't want you to think that, oh, they're also dialing these temperatures down. We still run it hot. We use the WMA so that we have a good compaction aid in the field. So I'm going to talk a little bit about the air voids and what we needed to do there. So one of the things, we used to run our mixes at air voids at end design between 3 to 5% air voids, standard run-of-the-mill super pave mixes. And what we did, and you can read many studies that came out, and they have opted to lower end design air voids to get two things going on, to get a little bit more binder in the mixes, because the mixes were fairly dry, and get a little bit more durability. And I'll explain. We did it for that reason, but another reason as well. So we went to basically all of our mixes are 1.5 to 2.5 air voids at end design. So a target of 2. This is not a trade-off, because I don't want to say, well, we traded that off to get whatever. No, let's talk about the upside of lowering the voids. We get two things. We can increase dust content. We can also increase the binder content to lower those voids, collapse the structure a little bit. But the nice part about the lower voids is we get higher in-place density, and most all of you know that performance is related around density. And we also get, with the high density, we get mixes that are not permeable. So we're not getting water damage to the mixes. The mixes are also higher strength mixes for sure. Typically, as I said, I'm going to talk about the dust here, but we're going to get a little bit more dust in our mixes. So I'm going to talk about the dust after I explain to you what we've done with the VMA. Excuse me. So VMA calculation and specifying it is a big problem. It was a big problem for us. And now all these things I'm talking about, the DOT and the industry, you have to get comfortable with these changes in this approach. It's definitely different than super pave, but I'll explain to you why it works as well. We've been doing it here, as I said, 12. This will be going on the 13th year. VMA, why is that a big problem? When we're putting typically our mixes are running about the workhorse mix we use here in Nebraska is an SPR. It's 80% of our tonnage, and we run it at 50% wrap everywhere, bottom lifts, middle lifts, top lifts. When we burn that material off, get the oil off it in the ignition oven, we did a study of about 12 years ago actually to try to address this. Is what we have is the burn off oven running at 1,000 degrees lightens the aggregate up, so the gravity, the specific gravity is greatly lowered. Okay, and I know anyone who doesn't do these calculations on this presentation, it is this simple. Ignition oven affects it, it lowers the gravity, and the gravity is everything for the VMA calculation. So a higher gravity, you get higher VMAs, and that's what you're trying to do in these mixes is meet VMA. And what we found was, and I can get you a copy of our study, we use many different mineralogy type of aggregates, but it lowers the VMA if you use that ignition oven material by as much as 3%. So if you were targeting 14 or 15 VMA, by calculation, when you're done using it, you're going to look at something that looks like it's got 11 or 12 VMA, and that's not actually the case with some aggregates. Now, you need to do some of that testing on your own aggregates. Those are done on all the different aggregates we use here in Nebraska to see the effect of VMA. So how do you solve that? You can either fix the gravity value for the aggregate, which we did, but we don't use VMA for acceptance. You can also back calculate the gravity from GSE or go to a minimum binder film thickness or film thickness. I'm going to go through these fairly quickly, but maybe conversations after the conference or during the questions we can dig into it a little bit further. Let's talk about the dust. That's the biggest challenge that we run into. When we mill a roadway up, we generate a lot of -200 material. So obviously quite a bit more material of -200. So what did we do? We opened the grading band to allow a little bit more -200 material. And the VMA allowances, basically, as I said, we got rid of VMA as far as the spec. And so we've opened that part of it up, and we really viewed the dust as the binder extender. We actually needed some dust in our mix to bind it together a little bit better, help us develop that strength. So we collapsed the voids down with a little bit of dust and a little bit more oil in these mixes. So the dust to asphalt ratios, super pave recommendations went from the original recommendation to 0.6 to 1.6. We're actually 0.7 to 1.7. I'm going to show you mixed design towards the end here to show you typically what we run into. The other part of it is, you can see up in here in the top, if you follow my arrow, this is after the bag house. We're dropping dust out of the mix. So I'll show you a little bit more detail on that, but we need to control the dust and meter it back into the plant, and some of it we actually have to waste out of the plant. So now I'm going to switch gears just a little bit and talk about some of the plant modifications. I'll talk a little bit about the dust, that dust issue and how we deal with that in the plants as well. So obviously, I spoke to some of your folks before I did the presentation. You're using, from what I understand, about 20 to 25% wrap in your mixes, which is wonderful. I mean, that is a great, actually it's a very good amount, and it's above national averages for that matter. So you certainly know what good stockpile management is. If we have different lifts or different layers of existing asphalt, we need to stockpile that material separately. We need to manage those stockpiles well. We also have to do what I said was the -200 said material management. I'll talk a little bit about that, how we're dealing with that in a little more detail here. The other thing that the other areas, variable frequency drives, all of our plants, I'll talk about it here. I'm sorry, this is an intro slide for what I'm going to talk about, sorry. Dual wrap bins, and then I'm going to talk a little bit about these screening units and grizzlies that we have on the plants. And the last part, I'm going to talk about the wrap processing. I was getting a little ahead of myself here, trying to answer everything on this one slide. So let's talk about the stockpile management at these plants. Very critical. So you need to be good steward of the stockpiles. As I said, you need to run the gradations of the material, and you need to run the binder contents as you're milling and bringing it in. As you know, you can get some variability within a 1 mile section of roadway. You can get some of that varying. So knowing the material that you have in for binder contents and the gradation is very helpful. One of the things that we like to do, and I'm going to talk a little bit more of that, is a lot of our projects, we do what we call hand-to-mouth wrap use. In other words, we come onto the project and we're milling the roadway. It's coming straight to the plant and almost just feeding the plant. So don't get me wrong, it's not literally from the truck right into there. It's good to build the stockpile up so you can monitor any quality changes in the wrap. But my point here is that if you can mill and use the wrap immediately, it's going to eliminate processing of the wrap. I'll talk about that here in just a minute. This is the big challenge, the 200 material. basically, so these photos I want to talk a little bit about. On the bottom left, that's your bag house, a typical old CMI plant bag house, and it's running it up here, and it's going into these whey pods then. And this is actually the same plant then. Part of it is going back into the plant, and then part of it is being dropped down in this auger. These are hoses with water to control the dust, and basically it puts it into this pit, and we just waste the material. On the far right, that's actually a lime silo. We don't use lime anymore, so people here are using this to store and manage that flow of dust that may vary in the mix. But the key is that we're able to meter it back and control the -200 back into the plant to maintain the consistent volumetrics. So yes, we do, most of our projects, we do drop some of the dust from the plant. Talk a minute about these variable frequency drive plant controls. All of our plants run VFDs now. It helps us gives us precision control of the plant rate. All of the new plants are all variable frequency drives. We had a few older plants, they retrofitted them and changed them into variable frequency so they can run the drum from 0 to however speed they want to run the drum. They can also run the bag house fines and the exhausts through variable speeds, which is critical when you have to run at these very high temperatures. I'll talk about that here in a minute. And they also run all the cold feeds are all on variable frequency drive plant controls. So all of them are that way now. We had a few older plants, they actually retrofitted these VFDs into them. And then the wrap bins, obviously you brought in the bigger wrap bins, and I'll talk a minute about the wrap bins and where we're at now with the wrap bins. So here is, I'm going to talk a little bit about why we had to get to variable frequency drives and with flights and veiling. On the top right here, this is it looking, the red dot would be where the heat, the flame would be coming in for this. These are drum plants, so this is a drum plant. And you can see these flights here. One of the things we had to do is we did have to make some modifications with these flights. I have another slide that I can show you. Because we have to get that virgin material. If we're running a 50-50, we got to get a lot of heat into 50% virgin material. So once it's blended with the cold wrap material, that we can still meet these 300-degree exit temperatures for laydown. So in general, our findings have been the drum plants that we use, maximum we can run about 50 to 65% wrap. We have a couple mixes that we run 65, but our workhorse pretty much, as I spoke earlier, is we're running 50% wrap in these mixes since 2008. Batch plants, we don't have any more here. We had one a number of years ago, but when I was out on the East Coast visiting a DOT, generally, I don't know that you guys have any batch plants. I think someone said you didn't. But if you had one, they're probably limited at 35% wrap because of the moisture that's in the wrap. And when they finally introduce it, that moisture flash from the wrap, that's the limiting factor here. So I think in a batch plant, you're only going to see a maximum of 35, maybe even a little bit less, actually. So talk a little bit more on these VFDs and these flights. There's a little blown up picture of that from that last slide. So this just shows you the combustion flights. Some of these flights are these are called basket flights. And so what the trick was here was you've got to get this aggregate to be very accurate in veiling over this flame. So we're very efficient in the heat transfer so we can superheat these aggregates. So this wasn't major, but all of them went through some adjustments. Most of these, in fact, I would say all of these companies that make these plants are very aware of the things I'm talking about because all of our contractors went through these minor modifications. This is not a major modification to go here. This is our latest plant. I just wanted to show you this. This is our latest plant that was built, actually it's in Lincoln. And you can see here's the cold feeds coming up here and up on this top left. And then back here about in the middle of the plant, This is the wrap bins going in. So the heated material comes down through here. The wrap is introduced. It's a double drum, so it goes down and then it comes back up the outside of the material. Sorry about that. Outside, but this is kind of the interesting part here. We have another drum. This drops into a drum to continue the heat transfer and mixing material, and then it goes from there up into the storage silos. Very nice plant. These are the things that we're going to be seeing a little bit more of as the wrap use and recycling gets more optimized. The other thing I think that you're going to see is preheaters. So if you were to take this drum and put it over on this other side, if you could take the wrap, let's just say on a 70-degree day, if you could take the wrap and add just 30 degrees to it, so get it to 100 before the oil gets lively, the preheaters then dump them into the plant, we can run the front end of these plants not as hot. In other words, we don't have to superheat that virgin material quite as much. I think you're going to see more of that. I just wanted to show you this. This is a post drum to continue the mixing and the heat transfer. Very nice. Talk a little bit about these wrap bins. This is recent here. Dual wrap bins. So all of our plants, I would tell you, I think all of them now run 2 wrap bins. And this is only over the last 2 years. And the reason why is twofold. So number one, to handle 50% volume of wrap, it's much easier when you have 2 bins running 25% wrap each. The other one is a lot of times we may have 2 different wraps on a project. And so instead of, before we had 2 wrap bins, they would run the project with one mix design using this wrap, and then they'd have to switch to a second mix design and switch over to the other type of wrap. And the nice part of this is that they were able to, they can run both wrap through the duration of the whole project, one mix design, and it also gives you a lot better control. I'm getting a little close on time. I'm going to, I'm almost done. I've got a few more slides here. I want to talk a little bit about these screening units. You can see on the bottom left, this is a wrap feed here. You can see how much wrap we're putting in there just visually. And then some shots of regular screens, slotted screens. And then this far right on the bottom, this is the most typical of what you see on plant site setups, is a whole variety or assortment of screens depending on what type of material, what type of oversize they have to deal with, and they make these adjustments on these grizzlies or these screening units. So you really need to have this. Most plants do. I'm not telling you anything new. You've got these on your plants already if you're dealing with 20 to 25% wrap. The thing is, it's just important so you don't have a lot of waste of material either. And you want to screen off the bad actors of the wrap. Sometimes we even see these feeders will have 2 sets of screens in there. And this is the last one. Let's see here. Oh, this is, I'm sorry, the last item would be this item. And that is the wrap processing. And so for us here, I talked earlier about this hand-to-mouth feeding of a plant. The way we started over the first 10 years, we just milled the roadway and then we ran it straight to the plant, stockpiled it, and ran it right in there. They were fresh millings. They weren't all, on a hot summer's day, they can get compacted back together. So the best is to mill and run straight to the plant. The other thing for the pavement designers, that's what I used to do, was in pavement design. The other part that we do is that we try to balance the project. I would say it's roadway mining. In other words, if we're putting just a 2-inch maintenance type of overlay, we want to, as long as the roadway has good structure, we want to be able to mill 1 inch, that we can generate the millings right there on the project. So mill 1, put 2 back, it allows us to get the 50% material right there on the project. And so it's kind of threefold. The benefit, we get half the oil is free from the road that we just milled. Half of the aggregate is free. And the other item that people don't really think about that much is we don't have to haul half the aggregate in from a quarry and haul it over all these haul roads and create additional damage. So in other words, we cut the raw materials and the loading on the roads to get to the project by half. So try to do that. Again, you got to be comfortable in your designs, but I'm just saying these are the things that has worked for us. And so we deliberately, as long as number one, the road can handle the structure, we try to mill and generate the millings right from the project. The other thing that's very new here, we don't pre-process, we don't do any fractionating yet, but the number 2 item on the bottom right here, this honey badger, I'm not selling for them. I just, somebody had this on their plant, and what it is kind of a pre-crushing unit, so they're not having to deal with the screens pulling off so much material. 2 things, if you get to these higher wrap amounts, I highly recommend. This has been one of the best things as far as processing the material. The better you process it, it's going to run through the plant that much better, and it's going to lay down that much better. So here's a big slide. How long does it take? You know, if you're already doing 20 to 25% wrap, you could do some now, and you don't need to go to 50% wrap. Try to get to the next step of 35% wrap. You can do that. If you're doing 25, you're doing very well. I don't have any dog in this fight. I don't, I work for Nebraska DOT, but I know what's stretching our dollars and our paving tonnage quite a bit, and that's through these using the recycle. So I don't think the step is that hard for you, but you do have to, the designers have to get comfortable in the specifications of being able to go to lower air voids. So one of the questions that comes up, I might answer one that may come up here later. I'm doing okay with time. Here's the secret sauce, okay? So volumetrics came out so you don't have any rutting and all that. And quite frankly, it dried up a lot of the mixes for the binder content. By lowering the air voids, this is not a trade-off or a compromise. We get better density, less permeability, higher strength mix, but here's the secret sauce. You still have very good angularity in the mix. That's the number one thing. The other 1B, 1A and 1B is we're using really, really good polymer modified binders. We're putting super glue in these mixes. And so when you're using the super glue, these air voids aren't as critical because we're designing inherent strength into the mix by lowering the voids and using these very good binders. Real quickly, when we decided in 2008, I didn't even know if I could get a -34 grade binder. And so I went to the industry, and ours is, I'll share with you, is Flint Hills and Jepro. Now it's Ergon, but we had Monarch, we had Western States, Suncor Oil. So those are all of our suppliers here, great suppliers. But I went to them. We didn't even know if we could get -34. And we said, if we go, not just can we get -34 grade binder, but if we commit that all of our binders are going to be -34 grade, are you in? And they said, yeah, we're in. And I think some of it is that they're able to buy straight run, the softest binder on the market. In fact, we just had a combined states binder group meeting last week, and a gentleman from Husky was on there, and I had a few questions for him. Very interesting what he said. So we get this XX -34 binders. He said the softest straight run crude they make is a -37. So I believe now for the last 12 years, I've been getting basically a PG XX about a -37 because they need to cover themselves so they're not out of spec on the -34. So I think we've been getting it here for a number of years. So, and you can get it there in North Dakota. The low end temperature, if it's necessary here, obviously you guys need to cover that low end temperature as well. So just a little backstory on the binder, but we committed to all -34 grades, and the industry totally stepped up to it. It was a nice thing. So last but not least, so this is today's typical mix design. This is what our, sorry I didn't cover up the names. James Johnson's probably going to sue me or something, but anyhow, all the names are on here. But the point on this one is, I just want to show you, this is our typical mix design. So very typical. We have 3 virgin materials, so 3/4 inch rock. We have a 3A crushed gravel, very sharp crushed gravel, 2A, which is round road gravel, straight run, and 45% wrap. This is this SPR. I told you, it's our workhorse. We do it all over the place. A couple other things I'm going to point out to you. Dust. Now you're going to say to yourself, this isn't horrible dust content. Very typical for us, 5.6. But still, you're running down here. I mean, if you follow my cursor, we still run above the 1.0 dust asphalt. So we definitely introduce a little bit more dust into the mix. The other one is, here's the super glue. This is a 50, this is MSCR greeting, but it's a 58H -34. And then we write over here, 0.7 tenths, add here. This is an Armaz H. I'm not selling this for them either, but Armaz Ultra 1, good product as well. And quite honestly, since 2008, I didn't go and count them. We've done well over 1,000 of these mixes for sure. And then to give you a little more idea, we've got to be getting close to about 20 million tons that we've put down on the ground since 2008. We don't have any failures, nothing catastrophic. We do get a little bit more cracking in the mixes, but it's not enough to. 30 to 40 million dollars of crack sealing or savings can do a lot of crack sealing. We're already sealing mixes without any wrap in them, quite frankly, and that's reflective cracking. So no failures. We've done, yeah, like I said, nearly 20 million tons, and most of it has been this SPR mix, and all of the SPRs run between 40 to 50% wrap in them. So last but not least, that was last summer in the middle of COVID. Went out back and latched into about a 5-pound largemouth bass. So that's my fun part of last summer. There wasn't many others. So anyhow, with that, I don't know, Terry, if you want, I'll just turn it back over to you, or if we're going to do questions later in the conference. But thank you all for letting me come and present. I will encourage you this. I did not talk to any of our contractors but in Nebraska. You're more than welcome to call them. And they all run 50% wrap. All of their commercial work is 50% wrap. They would not have it any other way now. They run all these plants, they're geared up. In fact, they would fight you to get away from using wrap in these mixes. But I encourage you, if you want to get a hold of them, I'll give you some contact people, and just at least you can learn some of the tricks that they went through on these plants. You don't need to reinvent this wheel. We can definitely help you and share in what we've done over the last number of years. So with that, thank you again for letting me come and present for you guys.
Good job, Bob.
Thank you, Jerry.
Dustin, do you want to pan the audience to see if there's a few questions that might be asked? Bob, you have a few minutes to answer a few questions. That was a great presentation. I'm sure that somebody in the audience might have a question, so if you please do, just let Dustin know. So Dustin, I'll turn it over to you to ask the audience if they have a few questions for Bob.
We do have a couple here. One is for wrap aid agents. What have you used? How do you like them? And how do you specify them into the job?
The only aid that we're using right now is the Warm Mix, the WMA. We mandate 0.7% because we know we're going to be using wrap. And so some folks design WA dosages based on wrap content. We know what our doses are. We know we're going to be running very high wrap. And so sorry about that. So we mandate the WMA, we have a list of approved products, and we run all 0.7% based on binder weight. We do have a 65% wrap mix. We actually specify 0.9%. Now the other area is recycling agents. We've spent the last 4 years doing research. We've got some very good progress. We're not speccing it yet, but I think here we're going to be speccing it probably, I would hope, within 2 years. And I believe we're going to be focused around corn and soybean-based oils, vegetable oils. We won't spec it that way, but we're doing a lot of work with all of the recycling agents, whether they're a tall oil, a vegetable oil, or even recycled oil or petroleum products. So we definitely think it's going to be coming. We're not quite ready here yet to use it for prime time.
Bob, we have another question. You talked about using the WMA, the warm mix asphalt aids for compaction. What about compaction aids that don't qualify as the warm mix additives, but still aid in compaction? Have you used them with your wrap? Can contractors use those?
No, we have not used them. I think that I'm going to answer, this is pretty complicated. I'm going to answer with a very quick answer though, so this could take a lot more discussion. The warm mix we use is twofold. We use primarily that it's an anti-stripping material along with the warm mix. So initially these were all super high quality amine base. So we don't just use WMA part of it, we use it also as an anti-stripping material. My answer is that yes, you need to just test the material, and people get paid on the density, and the good products, they work themselves through the market anyhow. So we did it. Why did we come up with approved products? Our approval was based on TSR and anti-stripping capabilities. So just so you know that, again, that's a whole nother probably 4-hour presentation, but good question, because it's important that I answer that. You definitely could use any WMAs that is working for you.
And another question, how many states are requiring separated reclaimed or separated wrap piles?
I don't know how many states. I would say, again, we didn't spec it. Well, it by our specs and acceptance process, they found the 2 wrap bins did 2 things. Number one, to handle such high volume of wrap, or if one gets plugged, the plant doesn't have, I mean, that's a major issue, but to handle 50% wrap, that was the number one thing. The second one was to run 2 types of wrap. To be honest with you, how many projects a year that they will split out the types of wrap? I'm going to say maybe it happens 1 out of 5, but they're getting cores from the roadway, they're cutting them, and if there's distinct values, they weigh the economics of, can I mill it all in one and get good blending? That's an option, but if there's quite a bit of difference, sometimes they like to split it out.
Thank you, that's a great response. Have you, or did you do any performance testing on the higher wrap mixes when you were starting out, or did you just jump into this?
That's a great question. Initially, we really didn't have a lot of performance mixes, I would tell you, that we were good at yet. And so we initially went in and we were just looking at stripping. We looked at rut resistance. We did not know initially in the cracking. And you know, necessity was the mother of invention. In 2008, we had projects that they were saying they may not get even oil to finish the project. So we went into that, and you know, it's just nice to be able to show you 12 or 13 years later, we're getting performance. But the answer is no, we didn't initially have a lot of performance testing that we could do and that we're really good at either at the time.
So next question, what is the price difference and availability generally between the 5828 and the 5834?
I think we'll emphasize general. Generally, I always tell my designers that every modification, and this has been my entire career, I've kind of based it on this. It usually costs us about $40 a modification. So to go from 5820, let's say 5834, let me take that back. No, that's a better example. To go from a 58 minus 34 to a 64 minus 34, it's about $40. It depends on the price of SBS, because we spec that you've got to use polymers, but typically $40 a liquid ton. That's what I use as a rule of thumb and what I tell my designers. Here's the ballpark. You can go on our website and look at average unit prices for the entire year to see exactly what those numbers are. But generally, I always say it's about $40 to $50 a liquid ton for one modification.
And Terry, if we have time for one more short question, and
Yep.
Bob, that is, love the contractor incentive, but how do you calculate that savings that's split between the contractor and the state?
So for mixed type SPR, we'll say, we set the, we need to sit down. I'll tell you quickly, but this is a lot more conversation to get it exactly right. But we take an SPR, and the typical mix on SPR, it runs at 5.2, let's just say 5.2% oil. Then when they run the job and we end, because we're paying the oil separately, and they run 3% at the end of the job, they have saved 2.4% oil. We can calculate that back in on the project tonnage, and then their bid price on the oil, and then times the 0.15. We can get into that detail a little bit more. There's going to be some questions. Well, what if someone's a little higher in their oil prices? We'll get into those details. That's not the case. I can show you numbers to back that, but that's basically how the calculation. We established the fixed typical of what SPR should be running, 5.2, and then after that, whatever they saved and they ran the project for, that's their net savings in tonnage times their bid price times 0.15 if it's on project. If it's off project, we'll get into that detail some other day, or if it's contractor owned, they get higher incentives because they own the material. So, but the state still gets the savings. I mean, it's a win-win, quite frankly. But we'll get into that detail a little bit more on a later day.
Okay, back to you, Terry.
Awesome. Great job, Bob. Great job. Thank you very much, Bob. I tell you what, once a bunch of bad piles of wrap material now looks like it's definitely going to be a valuable asset to everybody that they can use. Once again, if you just look at what Bob just went over, he's talking about learning, evaluating, and implementing, and the success that they've had with wrap in Nebraska. So there again, just a great presentation for all of us to learn again from. So with that said, now we're going to take a break. And once again, it's just going to be a short break. So we'd love to have everybody back at it here at 10:30 so that we can move on to the next session. So, and as you can see, we're going to thank the First Gold sponsor, Swanson Equipment. So with that said, let's go for a break. We'll see you back here at 10:30.
Oh, Terry, nice job. Bob, that was incredible.
Okay, yeah, thank you.
Yeah, very good. I mean, I tell you what, all of us in this industry, see those piles of old wrap material, and now to be able to use it as an asset. I mean, it's just amazing the cost savings that from townships to cities to counties to the DOTs from top to bottom. Can you see those piles as successes? So that was very, very good, Bob.
Yeah, there are no piles around here. In fact, they fight over the millings, and that's the truth. They when we first did it in a change order environment, where we said, hey, you got a project in 2008, you want to try the SPR? In a change order environment, we're saving 20% of the contract price in a change order environment. It was a lot of money. I mean, it was a lot of projects, $300,000 to $500,000 per project.
Wow.
Yeah, and that's a lot of money for any entity, especially, you know, let alone DOTs, but you take the lesser scale with the counties and they're getting the municipalities and even townships, you know, $300,000 to a county, that could be a whole nother project. So, you know, it's paying for itself. So talk about a great return on your investment. So very impressive.
So are they going to do more questions later then?
Are you able to stay on, or would you like to maybe go through questions now and some responses? Because some of our audience will still be there and listening.
Oh, okay, yeah, that's fine, sure.
Okay, so another question, the $40 per ton, is that liquid ton or is that hot mix ton?
Liquid.
Wow.
Yeah, so figure binders our binders here are about they're running just say 600 a liquid ton, and then for one modification, just figure you're in the 650 range. You know, I always, you know, there's some people who don't want to talk about the pricing. Well, no, these are average numbers of what you see. And my goodness, when I started, I think binder was $100, less than 100 a liquid ton. So, but yeah, about $50 is, and obviously that's driven by the polymer. Hang on. I had to switch in my headphones. That's obviously driven on polymer pricing and stuff like that. But, you know, right now we seem to we've had a consistent run of abundance of polymer, which is thank goodness. But I would emphasize, you know, we use really good binder. We're blessed with some pretty good binder here in the Midwest. If you know, you gotta, excuse me, spec it.
So on the polymer end, is there a difference between polymers based on the manufacturer?
I don't know. I don't know that. You know, most of ours are SBS polymers. It seems like that's the go-to, but yeah, the suppliers, that gentleman from Husky was wonderful to talk with. He gave me some good insight. And I think that's what you would see though, that simple, I don't want to say it's simple, but that most of them I think are buying this XX minus 34, and then so it's about a 49, and then they're adding some polymer to bring the high end temperature up. It really doesn't affect the low end. But keep in mind, if any of the designers are listening too, is the problem is not the high end. We're trying to solve what's going on the soft end and these the minus, you know, we want to get an end resultant somewhere near the minus 28. I'm sure many people have seen a lot of presentations on blending charts and running the wrap and then trying to calculate, well, good luck trying to calculate how much oil falls off the wrap and then blends itself with the oil. And our approach was basically, no, let's just get the best oil we can. We know we have a low temperature challenge, so let's just get the best binder. And that's the best you can get on the market. To get minus 40 grade, that's what the gentleman from Husky had answered my question. You really can't get a minus 40 without then going to recycling agents, either tall oils, vegetable oils, or petroleum products, fluxing agents to soften them up, which is what we want generally. I shouldn't say this, but generally, if you can get it out of straight run crudes, the better off you are to begin with. And trying to put the cream back in the milk is a little challenging.
Well said, the cream back into the milk. So another question, with the higher WMA, or mixed asphalt additives percentages, do you allow lower minimum air temperatures for paving with these mixes, and how is the performance in colder weather? You had talked about keeping the temp up, but do you allow it? And what about colder weather?
Great question. You'll know when you're running wrap at 50%. If you went to 35, you're not going to quite see the effects we see at 50. It's certainly a stiffer material. Colder temperatures. The other thing that we've went to help our mixing is we now pave. This is just this last year. We use MTVs on all of our stuff. Now I don't want the industry. I don't want them to panic and go, oh, now we're buying MTVs for everything. It's a good move for us. It helps the remixing in any time of the year, quite frankly. But the answer directly on the warm mix is that it's purely compaction aid, and you definitely see the stiffness. So we, even if we didn't use wrap, we pave till the end of October in a normal year, and we're out there, and you got to keep those rollers right behind the paver, even if we aren't using wrap out there. But there is definitely some more stiffness in there.
One more question in the Q&A. At the time of the mix design, how are you determining the asphalt content of the wrap?
Okay, yeah, great question. So we get rid of the VMA. So one caveat here, we control it purely with air void and binder content, okay? And so number one, we don't have super high absorptive aggregates, because if you did, then you run a risk of air voids plus the oil, but all the oil went into the aggregates. I'm not getting film thickness. That's why I mentioned on that slide, if you have some absorption issues, you may need to look at like a minimum film thickness. For us, it's purely driven off the voids, and we do have a minimum on all of our mixes. We do have a minimum AC content. Why? We've been making hot mix here a long time. Even though the designs have changed a little bit, the gradations, even if you looked from the 1970s mixes, very dense mixes, we know about what these minimum ACs need to be. And most, just as a rule of thumb, almost every one of our mixes are 5.2 oil. We have one that's a 5.4 minimum, and then we have a base mix, the 65% recycle, that the minimum, I believe, is a 4.8. It runs less oil because it's a lot coarser. We spec a bunch of rock into it on kind of a roads that have some real structural issues that we're just trying to beef up a little bit. So, but generally, rule of thumb, we've established from our historical knowledge, and it's just a minimum. So most of our mixes, quite frankly, run about 5.4 across the board, as a general rule of thumb. I hate to generalize it, but that, until you go and look at these other 1,000 designs, you'll get the feel for it. But yeah, about a 5.4.
Right, Terry and Bob, there's still Q&A coming in, but we're close to our startup time. Terry, I'll turn it back to you. Bob, if you're still online later and there's questions, Terry may interject.
Okay, or we'll set something up too, maybe another web just for industry folks and walk through it. It'd be really good discussion, I think, for everybody.
Well done. Back to you, Terry. Thank you.
Great. Once again, I'd like to thank our last speaker, Bob. Very nice presentation on wrap. How was your coffee break? Everybody's used to normally rubbing elbows at coffee break with the conference sponsors, so we'd like to thank those guys again. Dustin's been screening, rolling them on your screen, so there again, the sponsors are great. The only thing I'm missing was be able to have coffee and a donut or a pop with your fellow constituents. Everybody likes to rub elbows, so now everybody sit down in their chair, rub your elbow. Now we could say we rubbed elbows with everybody at the meeting, even though it was virtual, so we rubbed some elbows. Next, welcome back. There again, now we have up the UND Senior Design, which is a great partnership with UND and the North Dakota DOT. Here to tell us more about their project, which consists of severe transverse cracking and how to address it with the DOT project coaches, mentors, and the asphalt experts, is Amy, Kurt, and Andy. I'll give a little bit of bio from each of them. First of all, Amy Bisey. Amy Bisey is the team lead for research and pavement design at the North Dakota DOT. She oversees the operation of the research program, issuance of concrete and bituminous thickness recommendations, falling weight deflectometer, data collection, and pavement profiling. Amy's goal for research within the North Dakota DOT are to identify the state's greatest transportation research needs and promote impermeable cost-saving solutions. Amy has a bachelor and master's degree in civil engineering from North Dakota State University. Next, I'm going to introduce is Andy Ayash. Andy Ayash is a research and pavement designer engineer with the North Dakota DOT. Before joining the DOT, he worked for several years as a project engineer and enjoys applying his construction background to relevant and practical research projects. He is a professional engineer and is a graduate of NDSU with a bachelor's degree in civil engineering. Last but not least, the third member of the team is Kurt Dunn. Kurt Dunn is the Highway Material Coordinator with the North Dakota DOT in the Grand Forks District. He earned a bachelor's degree in civil engineering from the University of North Dakota and began his career with the North Dakota DOT in 1995. Kurt is a registered professional engineer and has taught soil certification classes for the department. Kurt serves on the North Dakota Asphalt Steering Committee, the Transportation Research Innovative Program, and the Research Advisory Committee. He also serves on several study groups researching topics such as intelligent compaction and percent within the limit specifications. So without further ado, the three individuals, Kurt, Andy, and Amy, are going to start their presentation. So here you go, guys. Have at it.
Thank you, Terry. Yes, we are really excited to be here today and talk about this project. You know, Kurt and I are both on the Asphalt Steering Committee, and one of the things that's really important to the committee is to tie the conference content back to the theme, which this year is Learn, Evolve, Implement, Succeed. And so this was a really naturally fitting topic, UND Senior Design Project, because there was a whole lot of learning that went on here, and it was a really unique partnership between the DOT and the UND civil engineering students. So how this started is UND was looking for some problem statements for their 2021 senior design capstone class. And our former Grand Forks district engineer had this idea. There's these depressed transverse cracks, and it's really a universal problem. We see it all over. And there's a segment of roadway up in the Grand Forks district that really had some issues with this to extreme extents. So this segment of roadway, it's not extremely high on the performance classification system. It really doesn't have a lot of ADT, but there's a lot of agriculture in the area. So there is a decent amount of truck traffic proportionally. So the damage factor is there. The damage is high from trucks. And it was really to the point where just normal maintenance activities really weren't cutting it for this project. There was an overlay done on it, and just within a few years, the ride had already deteriorated to back where they had started. So that's really where the problem statement came from, to look into investigation, analysis, and design of hot bituminous pavement strategies to eliminate depressed transverse cracking in hot bituminous pavements. And so I think that for the future civil engineering workforce, this is actually going to be a real challenge that's on their immediate radar. You know, we're not really in the mode of building the transportation network anymore. We're in the mode of how do we keep these networks going? And this inheritance of really poor conditions and pavements that were built years and years and years ago with less than desirable materials, it's really something it's a challenge to us, and what do we do with them when we see these things? So here's the team. We got our students. We got to give a shout out to them. We got Joe, we got Cole, Rory, Mitchell, and Carter. And their academic advisor at UND is Dr. Nabil Suleiman. So where the DOT fit in is we served as agency mentors to these students as they worked through this project. So we had Kurt Dunn, the district materials coordinator for the Grand Forks district. We had Andy Ayash and myself. We work in the research and pavement section and materials and research. And really, everybody had something to learn from this. The students wanted to learn from our experience. And then us, we see this transverse depressed crack issue everywhere. We want to learn more about what's going on here too, and actually dive into it a little bit deeper. So one of the goals really was to give the students some hands-on field experience, actually let them see the problem up close and really take it apart and ask what is going on here. So we facilitated a really neat field review with them, and Andy and Kurt are going to elaborate on that. But as far as like the communication aspect, this is what it looked like a lot, which is something we're all really familiar to seeing at this point. But what I really want to highlight is I really do think that the power of technology as a communication tool that everybody has been embracing this past year, it's actually really exciting. You know, we got UND and Grand Forks, but I'm in Bismarck, Andy's in Fargo, Joe was in Minnesota, Rory's actually from Alaska. So just being able to all communicate and work on a project together and share resources, that's pretty exciting. So with that, I am going to pass it over to Andy, and he is going to tell us more about how we actually learned about what's going on in these transverse crack areas. So over to you, Andy.
Thank you, Amy. So investigation and analysis of the cracks, that's the project statement. And as Amy said, we don't want the students to just deal in theory. We wanted something hands-on. So we planned a field trip. This is the project location. This is Highway 32 from the junction of Highway 5 going north to the Canadian border. And the major town you would pass through on this stretch is Walhalla, North Dakota. It's the northeast corner of the state. It sees some of the most extreme conditions in the state. So we know that this stretch of roadway is experiencing this severe cracking, but we also know before we go in the construction history of the roadway. We know what we are expecting to see. So if you look at this, you just see a few things off the front, and what I see is that the road is relatively old. It was built in 1958, but what I can also see is that there hasn't really been a lot of construction in the last 50 plus years on that stretch. So if you add up the projects and you add up the layers, what we expected to see out there in this pavement layer is 5 inches of asphalt, with the top 2 inches being relatively newish asphalt, 2 inches of stabilized base beneath that, and 5 inches of aggregate base. I think it's important to just remind everybody now about the existing conditions that we're seeing out there. So if we go to the next slide. So this is an example of the depressed cracks we're seeing. This gap between the straight edge and the roadway is about 1.25 inches deep. It severely affects the ride. It allows infiltration of water into that area. It's severe damage. So this is what we want to evaluate. This is the section of the road that we want to evaluate. How do we do it? How do we get into the pavement layers? So that's what our field trip entailed. So our site visit was planned for October 7th, 2020. And in preparation of the team going out there to see the conditions, the Grand Forks District sought out 2 sections of roadway. So the first section is that cracked area that you saw from the previous slide. And the second section, it was about 30 to 40 feet south of that crack, was a control section where we weren't seeing any cracking. Same pavement age and everything, but really no cracking damage. So it was a good example of a control section. So when we went out to the site on the morning of October 7th, this is the staff, this is the team that was out there to assess what was going on. So we have the Grand Forks District, not only the maintenance department, but the construction department as well, staff from there. Of course, we had the students come and their professor, and we also had members of the materials and research staff. So as you can see from the video, from the saw cut areas, we used a mini excavator to pull out sections of the roadway and get it down to the base layer. Now, one of the things that I was really excited about being asked to be part of this project is at Materials and Research currently, we're using new technologies to study base and subgrade layers, characteristics of the material, mostly stiffness. So if you look on the left, that's a dynamic cone penetrometer. that's existing technology that we've had for a while that assesses strength of soil and gravel using a California bearing ratio. But on the right is a new piece of equipment that we've purchased and we are in the process of testing that directly measures a resilient modulus. So I was excited to come out and try this on a real job, but I was also excited to present and share and allow the students to come out and see what we're doing at the department and then get their hands on some real technology that could potentially be used in the future. And so you see on the left, that's Carter, and on the right, that's Mitch, and they're just demonstrating how simple and easy it is to use that machine. Now, in reality, an actual test, you saw 1 drop there. In reality, a real test is 6 drops, 3 to seat the machine and 3 to actually get the calculation. That being said, the total test takes less than a minute. So it was very, very fun for me to share that with the students and get them some hands-on experience. So also along with those tests, the experimental type tests that we're doing, we did do current tests. So you can see in the background, Chad is doing a sand cone, and in the foreground, we have a DCP test going on. So we have experimental and current, old and new tests, and we use that data to give the students all the tools they need to find solutions to these potential problems. So that's our field trip. Now I'm going to pass it off to Kurt Dunn, and he's going to get a little deeper into more testing that we did and specific material characteristics that we saw out there.
Okay, thank you, Andy. And so I guess, you know, primarily the students were challenged to figure out, you know, how to fix a pavement that's actually in this condition. And in order to really, you know, and just like anything else, to figure out how to fix something, you got to, you know, figure out what's wrong first. And so this was what was neat about this field review. It's sometimes it's not obvious when you drive over a pavement and look at the surface what's actually happening. And so this was kind of a really a neat thing that we could actually remove the pavement, and in this case, in the middle photo there, we removed all the asphaltic material, and then you know, it exposes the base, and then from there we could go down and look at the subgrade too. So so in addition to the newer tests that Andy showed us here, the students were able to you know, get some samples of the base material and the subgrade material, and run some of the traditional tests like gradations, physical properties, in-place densities, maybe using a sand cone, and doing some proctors. And we also did some coring in the right photo there. That's my lab assistant, Chad Taylor, who was very helpful out on the field review that day. I ran a lot of the tests that Andy brought along, and also did he's actually coring through a depressed crack area, right at the crack, and then a couple cores on each side of it. And also he ran a lot of the material testing afterwards, and provided the results to the students. To the left is Ken Swadine. Ken was graciously came all the way from Pierce, South Dakota to be with us that day. He was even there before I got there, over 400 miles. So, there's another great benefit of removing the pavement like that, is that we can actually analyze the cross section where the crack was there. And that was very interesting. So we're going to run a video on this, and go ahead, Amy. You can see where Ken is actually chipping away at some of the material right under the crack. It's obviously gotten weaker over time. And So it's probably not so much the top layer there, but some of the older middle layers, and there's this stabilized base there down in there. So then, as soon as he kind of moved away a little bit from the crack, maybe a few inches even, the material got a lot stiffer, so was more intact. So it's evident then that the moisture there is and the loads and things like that are causing some troubles. So this is a close-up of the cross section there that Ken was working at there. And a lot of these transverse cracks, they start from maybe a thermal crack in some of the lower layers, and after that, anything put on top of them has a tendency to reflect through. So pretty soon you have a full depth transverse crack there, and that really opens up. It provides a gateway for moisture and things like that to get in there. And if you take freeze thaw and combination of loads, and if the material is wet down in there, it can cause some hydrostatic forces that if the material is somewhat susceptible, it could actually start to strip some of that material and cause it to weaken. And you can actually see and down in the lower areas there, the middle layers, the older layers, and the stabilized base material is actually starting to depress down and sink down and weaken because of the loads. And so over to the right, so here's a screen shot of the base, more of a close-up of the aggregate base there. And this really wasn't like we normally spec, say, a class 5 or a class 3 today, but this was actually spec'd at that time in the 50s as just a pit run aggregate base. And so there really wasn't a lot of specifications or requirements, other than they basically just went into the pit and took it out and probably ran it through a sieve, maybe a 3-inch or a 2.5-inch sieve, and that was it. There was really no shale requirements, but we did do some gradations and we did do some shale testing on it, and that's actually Chad did that in the district there. And you'll notice there on the right there the amount of shale that was out there. And shale, of course, is very poor structural or building material, so it was more of a deleterious material. And there's actually around 24%. So actually a quarter of that sample was shale. So that was very interesting. Next slide, Amy. Okay, this is a really interesting slide, I think. More of a telling slide. Chad was doing some coring through the depressed crack areas. And if you notice from the earlier slides that the depressed crack is has the lowest depression right at the crack interface. And as you move out from the crack, it gradually lessens up on the settlement. So I would say on the one we were dealing with here, it was probably about 24 inches out from the crack, and then finally it gets back to a good the normal level where it isn't depressed. But so we took a core right at the crack, and then about 10 inches on each side of it, we took another one. So there's a little bit more settlement yet there. And then the last two cores were really kind of right at the edge where there was really no settlement at all. And so you can see from the middle core how evident it is that all that pumping action and the loads and things over the years of 50, 60, 65 years have degraded that area in there and really caused it to. You can see where it could actually settle. The fact that it wouldn't hold a core is interesting there. That it it's and these types of cracks, they just keep on sinking down. There really isn't a lot of things you can do. So as you can see, as they move away, it gets a little better, but and then the outside ones are a lot better. So here's a core. We took some of the intact cores, and we divided them up into those layers that we showed, that we're showing here, and we sawed them, and we ran bulks. We ran melted it down, ran some rice tests. And then we took the material, the separate material, in 3 pails, and we sent it into materials and research, where they or Joe Davis's section, and Bobby Usher actually ran some, put them in a burn off oven and ran the, found out what the residual binder contents were. So it's, you know, it looks about what you'd think you would get for the first 2 layers. And then, of course, the middle layer wasn't a super paved layer, so there's a little bit more oil that went in the old Marshall mixes and the pre-Marshall mixes. But the bottom lift was interesting because that wasn't a hot mix asphalt. That was just a mixture to stabilize it with some asphalt and some aggregates. So that didn't have as good of density, and it had a little bit more oil. So next slide, Amy. Okay, so that kind of wraps this up, and we're very grateful for everyone that participated in this, and it was, you know, we had a lot of different organizations. I mean, we had, you know, the Grand Forks District Maintenance and Construction Materials and Research, and the University of North Dakota, the students and the instructors, and Ken Swadine came down from Dakota Asphalt Paving Association. So we would like to thank the seniors for investing in this senior design project, and we wish them the best in their next endeavors. So thank you.
All right, thank you guys very much. What another great presentation by you guys. It's just also good to see the video and how the UND students work well with the North Dakota DOT. So great job, guys. Once again, it follows exactly what we've been talking about: learning, evolving, implementing, and then succeeding. All right, so now we're going to jump into the last presenter of the day today, and we're going to talk about the use of thermal imaging and IC data for quality control. This presentation is going to be put on by Todd Mansell. Little background, little bio on Todd. Todd has been in the asphalt paving and construction business for over 30 years, working as an asphalt laboratory and field technician, lab manager, field inspector, and quality control manager for both government and private employers. Todd currently is the production application specialist with Caterpillar Global Paving in Maple Grove, Minnesota. Todd prepares and delivers classroom and field paving and compaction training for Caterpillar customers worldwide. So once again, last presentation of the morning. Todd, it's all you, my friend. Rock and roll.
Hi, welcome to the North Dakota Asphalt Conference. My name's Todd Mansell, and today I will be talking about using thermal imaging and intelligent compaction data for quality control. So my name's Todd Mansell. I work for Caterpillar Global Paving based in Maple Grove, Minnesota. I'm a trainer and product application specialist there. So I've been very passionate about quality control for many, many years, as that was a former direct role of mine when I worked for a paving contractor. And I've continued that in my career with Caterpillar over the last 10 years. In terms of training and doing a lot of field job site consulting and all that type of stuff. So today, I would just like to share with you some of the things that I've learned and give a little background on using thermal imaging and intelligent compaction for quality control. So thinking about that, what problem are we trying to solve? So from an owner's perspective, and again, this is really my thoughts, so not necessarily a group think or anything like that. This is coming from me. But as an owner, we're not realizing in a lot of cases our design pavement life. So we design a pavement, and it's not that the design itself is necessarily bad, but it's construction related, so much of it. You know, we could do the best thickness design, materials, mix design, and the construction part creates the big challenge for us. So the pavement is only as good as its weakest link. And I always look at longitudinal joints are a good example. We can have a perfect pavement and the longitudinal joints fail prematurely. And again, that's just one example. And we'll see some other stuff here today. From a contractor's perspective, we're not always realizing our full incentive or bonus pay. And especially if we look at PWL specs, which I think are great because they're all about consistency. But there's other things in there, efficiencies and process, fewer roller passes, quality, production, operator training, equipment condition repair. So there's a lot of things that we can figure out and find, if you will, using these technologies, thermal and intelligent compaction combined. So when we look at temperature differentials, what does that lead to? Leads to density differentials or compaction variability. And this is a classic photograph that many of you have already seen from Washington State DOT. And on a morning after it rains, you can see the low density areas in a pavement. So just because of the moisture where it accumulates and sits on the surface. So a couple pictures here, you know, this becomes this, right? So on the left side, you see a longitudinal joint, for example. And again, that's just one example, but you see that moisture there on the, again, after a rain, shows up those low density areas. And then you look just below that on the left in the middle there, that joint ends up getting sealed because it failed prematurely. Same thing on the right, we're looking at a thermal image. A lot of variability there in temperatures that were mapped with a thermal camera, taking a picture behind the pavers here. And then you look at the bottom picture, that's, you know, what shows up years later. And again, much of the pavement's in good shape, but then some of these areas where we see these big thermal differentials have failed prematurely. And it costs us money to get out there and repair those, right? Whether we have one patch to make or several, if we have to close that road, that's interrupting the traveling public. It's costing us as an owner money to get out there, close that road, do these repairs. So again, like to talk about as these things relate to quality control. So under the current system, what percentage actually gets measured? It's a very small percentage, arguably, depending on how you look at it, less than 1% of that pavement, if we're measuring for density, actually gets checked. What do we typically do? 5 sublots per day on a highway job and 5 core locations. And we average those and each of those sublots for the day's production. But very, very small area of the overall area and quantity of mix that actually gets tested. So really want to look at applying technology to minimize that risk. And one of those tools is thermal imaging. And I'm really passionate about this because I've wanted this for years and years and years. I'm talking 20, 25 years or more as a quality control person. And at that time, the technology just wasn't there. Well, the technology is here now. So let's use it. So there's 2 types, right? When we look at thermal imaging, we've got handheld thermal cameras, and that's shown on the left there. We've also got what we call paver mounted thermal profiling, or PMTP for short. And then the display box there is showing what you might see on a paver, tracking or monitoring mix temperatures in real time as we're paving. So I just want to give a quick overview of the equipment itself, what it can do for us, and then go through a few examples. So when we look at this, paver mounted thermal profiling, continuous measurement of the surface temperature of the asphalt mat as we're paving. It's real-time information on the paver. It's near real-time information if we're looking at this in the office, if we're having this information sent wirelessly to a server and then able to view it through our desktop or our mobile device. And it's variable width, so we can adjust the width of the camera's field of view, if you will, when we're doing that. So we pave different widths, we can adjust that accordingly. And then all this information is able to be uploaded and analyzed in Vfds, which is the FHWA's software for analyzing intelligent compaction data, thermal data now, and even getting into some of the e-ticketing or the material management data system, as they call it. So that's paver mounted thermal profiling. This is just the specs on the Caterpillar version. MOBA has a version. MOBAs were the first one to commercialize thermal mapping behind the paver, and they've done it for many years. CAT came out with a system last year on the market, and some other manufacturers also have them now. Vogla has a system, Topcon has a system. So the industry's catching up, the technology's out there, let's use it. So these are just some specs, nothing to get into any details on, but again, gets into the temperature ranges, the accuracy. In our system, it's plus or minus 2 degrees Celsius or 2% of the range. So again, I'm not going to get into the details on all that here. What I really want to get to is the application and the benefits that we can see from it. So thermal mapping in real time, again, on the paver itself, which to me, and you'll hear me say this again, that's the real power in this thermal mapping. It's the real time part of it. When we can make changes while we're paving to improve the quality and efficiency of our operation. So how can thermal imaging help with quality control? So just a few things to think about: consistent mat temperatures, consistent equals consistent compaction, equals better smoothness and extended pavement life, which is, again, a lot of what we're looking for here, right? Just getting that life out of the pavement and not losing or not hitting our life expectancy because we don't build it right or because we don't monitor it right, even if we have the best materials there during placement. Other things: identify areas of improvement in process and equipment. So plant operations, plant repairs, transportation and hauling of mix. So loading trucks, transfer to the paver, through the paver, paving equipment setup and operation, paving equipment repair. So there's a whole bunch of stuff. And I've only listed a few things. As a contractor using this equipment, this technology, you're going to find things that I haven't discovered yet, or I haven't even listed here. And again, hopefully it'll just get everybody thinking. Now I want to talk a little more on thermal patterns and what do they mean. So when we look at this, it's pretty busy looking slide there. I've got a little video, thermal camera video. This is on Highway 1 near Dakota last year, and pretty nice uniform looking mat there. The real number I want you to look at here is up in the top right where it says auto and then the max number. And I can't go into all the details right now, but I didn't have the camera set up to hide those other numbers that they're not temperature, so I don't want you to get misled by that. So this is about 265, 270 across the width of that mat as they're paving. Pretty uniform. Very windy day, so again, it's surface temperature too. So the internal temp of that mix was hotter, a lot hotter than that. But again, we can see it was very uniform in temperature. So what's the rolling pattern tell me? Got Kurt and Ken there trying to figure that out at halftime there. But no, seriously, there's a lot of things we can look at and see from those thermal differentials. And I'm just going to wing through a few examples. So truck loadout's one. And here we look in the same picture on the left and right. One's the thermal, the other's the picture without the color pattern over it, the thermal pattern. But you look at the differences in temperature just in that one truck. And yes, I know there's a little bit of it's the crust, but you look at 311, 223, 308, 235, 310, kind of tells me I want to make sure that kind of gets mixed a little bit somehow in the truck dumping procedure that I'm going to use if I'm end dumping directly into the paver. Also makes me think about loading at the plant. And that image in the top left, you see, a cold spot or colder spot, for example. This truck box here, just standing there with my thermal camera, take a shot, an image of that truck box. I can tell you right now that was no 3-drop load, right? So there's areas where we can look quick and make improvements if we need to. And again, it's so easy, so quick to get that information. We can make changes fast if we need to. And the load segregation. So here, running the hoppers low, you got large rocks in the corners. If we run the hopper itself low, that's going to show up in the mat in the thermal image behind the paver. So kind of doing the I'll call it the reverse thing. We look at the thermal image and we see those cold spots. I'm going to go back and look in the hopper or just kind of watch the operator and see, hey, are you running your hopper down in between every load and causing those cold spots that we're seeing? Because they're going to be differential compaction. They're going to be potholes in the future, right? Not to mention the change in head of material and smoothness. So paver stop, for example, again, just looking at different temperatures when we stop that paver and we're looking in the hopper. So we're always going to have some temperature differentials, but what the thermal does is gives us a tool that we can look at really quickly, identify, I'll call some of them the low-hanging fruit, and then even drill down into some deeper operational type things. This is a classic slide from Minnesota DOT, just showing end dumping, and you can see the thermal differentials every truckload, right? And we've all been on jobs where we've seen it segregation-wise, physical aggregate segregation, end of truckload. So here, just showing it in a thermal image. But again, this is something we can look at. This information, that top bar there with the thermal image, that's running real time on the paver. So the screed operator can look at that, or the paver operator can be looking at this and going, hey, what can I do? Can I play around here a little bit with how I'm dumping those trucks or my hopper level to get rid of those lines? So to me, that, again, that's the power of it, is the real-time info for the paving crew to make those improvements in the field. Something else, just again, another example. So we're at the plant. This was in Quebec up in Canada. I took a thermal shot as that mix was coming out of the silo. It's actually, if you look closely at the scale, it's actually pretty consistent. It's another thing you always should mention. Make sure when you do look at these images, you're looking at the scale, or there's an appropriate scale, because sometimes it can look horrendous and there's not that much of a difference. But looking at that, you can see, I mean, it is hotter on one side than the other. So plant operator loading trucks, is this something, I mean, is there enough difference there? Is that something you want to look at on your equipment? Maybe you can to make it even better, right? Or the batchers at the top of the silos in good shape, or the conveyors loading the silos from the dryer drum in a good uniform manner. Are we getting more hot on one side and cold on the other? So again, lots of things to look at. This was Dakota, again, the portable plant setup there, and you look at these thermal images. Very good, consistent. So, literally 5 degrees difference, 4 degrees difference across the width of that dump from the silo into the truck. So I know I'm getting good, consistent temperature being loaded into that truck as it gets loaded at the plant. I'm not a plant guy, but again, there's your thermal. You can look at the plant itself, the dryer drum, the mixing drum. You can see the wrap ring over here on the right, where it's obviously a lower temperature, where it's insulated and you've got the wrap coming in. But just powerful information, and quick and fast, especially if, again, you actually know what you're looking at, which I do not in this picture. Put me behind a paver and I can be more used. So we've got thermal segregation going on here with the pickup machine, but again, it's not bad at all. But what I just really wanted to show here, and again, another MnDOT slide, but comparing, we looked at an end dump earlier where you could see the lines there, big differences after every truckload. Now we're using a pickup machine or windrow elevator, and a lot less thermal differentials there. The other thing I think is kind of neat, and I'll talk about this in a minute, is just the paver stops themselves. So the number and the time of those stops. Other thing we can use thermal for, just managing windrow temps, right? So this is I-94 near Medina in 2019. So doing a great job keeping the windrows short and not letting them get cooled off. Another thing that'll show up on thermal is if we do not back up and overlap our windrows, we'll see those little cold areas because the pickup machine picks up that area. And if we haven't backed up over that windrow and overlapped it, so it's a continuous windrow, we get that little cold spot, if you will, in between there. And another thing we got to watch, and it could affect our head of material as well. So we can look at a thermal image and go, hey, maybe I need to drill down here and just take a closer look at what's actually going on out there. Material transfer device, the last MnDOT slide I have, but they did such a great job of putting together the end dump, the windrow elevator, and the remixing transfer device. Again, at the very bottom, if you look at the 3 different thermal patterns, you can see the difference between those. What I don't want anybody to think is I need to go out and get a transfer device, because I totally disagree. I can get a great consistent thermal paving job using end dumps if I do everything right. So if one of these devices helps you do a better job in the field, by all means, by all the more power to you. But I am not, in my experience, going to say that any one of these is better than the other. Yes, I'm going to say that in a lot of cases, the transfer device helps my operation, or a pickup machine over just straight end dumping, but I can do the same quality with any of those tools. Auger speed's another one, so I can look at a thermal pattern. I can quite often tell if it's just auger speed by seeing the stripes in the mat. So if I got stripes going on there, is my auger speeds, my augers are going too fast, right? So top right, you can see a video. It's a little misaligned there, but if you look closely, you can get a good idea how consistent the temperature of that mix is as it's being augered from the conveyors across the face of the screed. And pretty good, that's very good auger speed, right? Half auger head of material, doing everything right. Bottom right corner, that video is just showing, you know, basically what they were doing in the top there. They've got good consistent auger speed at 20 to 40 RPMs, but the thermal image will show that. Auger height, slight change in auger height can change not only the surface texture, but also the temperature, surface temperature. So again, something we can quite often pick up quickly by looking at a thermal image. Conveyor speed, this is a big one. So I can look at a thermal image and see where those conveyors have been running really fast. This is almost what I'll call a classic. You see those stripes in the mat, temperature differentials, and I call it streaking, and that's almost always related to the feed system on the paver being set up to convey that mix back in a nice uniform and consistent manner. So if we don't have our feed sensors properly aimed, we get those augers going on and off, or the conveyors and augers together not moving in a nice uniform manner, we start seeing different patterns like this where we've got hot, colder areas. Again, classic indicator to me that the feeder system is not set up properly on the paver. And a lot of times, like in the bottom right corner there, it's that sonic feed sensor isn't positioned in the right spot or aimed in the right spot to get that continuous auger movement and mix feed back to the screed. Centerline streak, that's another one. So we see that on a, not as much as I used to see it years ago. And a lot of that is just due to the pavers nowadays. They've moved that gearbox that used to cause that centerline streak. Most manufacturers have moved that to the top. So now all you got are just chains and a sprocket at the bottom turning those augers. So centerline isn't as big a deal as it used to be, but it is still around, and there's different possibilities as to why that's happening. So if I see that on the thermal image, do I have lead crown on my screed? Do I have worn out deflector plates? Do I have my reversing augers set up properly, my kickback augers? I want you to look in the center here. So as this video plays, the center of the auger chamber, where the arrow is pointing right now, that's what I call a dead area. So just looking at this static thermal image right now, you can see the hot areas where that mix has come back off the conveyors. So I'm looking down into the auger chamber, and you get that area quite often causes the centerline streak. I call it a cold spot where mix builds up and never moves. So watch the little video clip here, and you'll see that mix start moving try that one more time. There we go. So you see all that white and yellow, the mix is hot, it's moving with the augers, but right behind that chain case, there's no temperature, it's cold. And it's just sitting there, that mix, not moving anywhere. It builds up, and quite often that's all that's causing that centerline stripe that we have. Lead crown, not going to get into this, more on the paver setup, but my screed plate's not flat. I can see patterns in the thermal. Deflector plate, so that little video clip I just showed, that's where the material can build up. The red dashed line is what it's supposed to look like. Mix builds up on there where the mix comes off the conveyors. And if it doesn't get knocked down with a shovel handle, or my reversing augers aren't set up properly, like you see in this picture, that's where that centerline stripe can come from. So again, it tells me my equipment's wearing out if it's not set up properly, or if there's just things I can do, tweak and change to make it better. So just an enormous amount of information. Hopper inserts, I can look at that. No, they're not all created equal. So this is something I can take a thermal image on my hopper insert and then run around behind the paver and look at the mat. I can make a change to it. I know a lot of contractors do homemade versions of these, or they put homemade baffles inside them to try and get better mix flow going through it. So again, the thermal images will really help with a lot of that stuff. Head of material, not really gonna, I guess a low hopper can lead to a low head of material, but when you drop that hopper level really low, again, you see the colder mix in the center there, right over the chains, and then hotter, warmer mix toward the sides to the middle, and then of course it's going to be cold on the outside edges. So what do we really want to do when we look at that? We want to keep that hopper half full, right? But I look behind the paver and see that. Then I go up and take a look inside the hopper, watch again the operation, just to see if there isn't something I can do a little better. Paver stop, screed settlement. You look at the picture on the left and the right, exact same photo. The difference there is when you look at the photo, the naked eye, you almost can't see that screed mark from that paver stop. You have to look kind of close. This was a 13-minute paver stop, I believe. And then you look at the thermal image, look at the temperature differentials there between the area in front of the screed, that'd be to your left on that thermal image, 220, 210 in the foreground. And then under the screed plate, the main screed, 278, and then under the extension on about 257. In the middle on a rear mount screed, that little middle area that sits there behind the screed, 181 degrees, 175, 78 behind. You've got 1, 2, 3, 4 temperature zones behind where that paver stopped. So what do you think you're going to see or feel when that paver takes off after a long stop and the rollers get there? You're going to have differential compaction, right? And you might get your density and all that. It's going to affect your ride or your smoothness, probably, if the stop is long enough. So again, I'm not picking on anyone on this paver stop. Just wanted to show the power of getting that thermal information and correlate it. So if you're going to run IRI now, you've got the location here. You've got the station by GPS from the thermal camera, the thermal on the paver. Now, when you run your smoothness trace, check it, compare it to those paver stops and see what effect they're having. And you can, as a contractor, you can figure out, well, if I stop 5 or 6 minutes, it's no problem. It doesn't affect my IRI, it doesn't affect my density. But if I'm going to stop for 15 minutes or 20 minutes or half an hour, maybe I want to pick that screed up, wait till I get the hot stuff and set that screed back down. Again, I'm not saying that's the answer, but you've got the information to make those decisions. And just another slide. This one was down in Louisiana. This was showing the same thing we just saw on the last slide. So 4 distinct temperature zones where we had that paver stop showing up on that thermal image. But as a QC guy, I'm correlating it to my IRI and my density because I've got the location from the IC roller. where that paver stopped as well. Paver stop report, this is I call the low-hanging fruit. The spreadsheet numbers on the top right there was from one of my jobs many years ago, and I tracked it manually, had a clipboard on the paver. I had different reasons for the paver stops, overload, underload, using a pickup machine, whether it was waiting for trucks, so trucking, testing, sampling, equipment breakdown, other reasons, which weren't one of those other 5 that were listed there. Each little box there for each day, so if you go horizontal, that's one paving shift. The total column here that I'm highlighting has got your number of minutes that the paver was stopped, and then the number of stops, and then the time, excuse me, the time. So again, huge amount of information. This was coming off the paver mounted thermal profiler, because it's it's keeping track of when that paver is moving and when it's stopped and where. And that's what you're looking at on the bottom right side there, is a map of paver stops going along Highway 1. And again, it's nothing bad or wrong with that. It's just amazing when you actually start recording that information and you start thinking, wow, maybe there's some things I can look at and try and fine tune or drill down and do a little better. Grade conditions, spills, I'm going to skip over this pretty quick, but that stuff is going to show up on a thermal image as well. That's really the whole point that I wanted to get across there. Banging tailgates out in front of the paver, same effect as spills if we don't have good flashing on the hopper. We've got that dragging mixer going over those cold areas where we had any of those spills or trucks banging out in front of the paver. That's going to show up in that thermal image as well. So a lot of things we can tell just on the operations side. Outside edges, I thought this one was pretty revealing. So thermal picture, we did a mill out on the main line, and then the shoulder, partial paved shoulder here is thinner, not as thick, because we don't want to spend the money to mill it out, or we're just paved right over the existing shoulder and put a thin lift over that. So thermal image showing the temperature nice and hot on the main line where we milled out, got some thickness, where it's thin, where we just paved over top of the existing shoulder instead of milling it out or doing something different. It's going to be different compaction. Maybe we care, maybe we don't, because it's a shoulder. But what I did see on this type of thing is right along that line there, the shoulder break. A few years later, what happens? Crack, crack, right? And it's because of that temperature differential, probably also to do with the thickness difference between the asphalt pavement thickness between the shoulder and the main line. But again, just something to look at there. We go over a high spot. So if our grade isn't right, or we're doing a lot of filling and scalping off with that paver screed that's trying to make a smooth pavement over top of an irregular grade, when we get any high spots, those are going to show up on that thermal image. And I know when you look at that, well, it's kind of late, right? So, but again, just a point to make, or as far as maybe the post analysis part of it, when we're looking at the job afterwards in the beta software or the manufacturer software for the thermal camera, we see these areas, and maybe we did not prepare that base as well as we could have or should have to eliminate, because those areas where it got real thin, those high spots where it shows cold in that thermal image, what are those going to be? Probably going to end up being potholes, right? Auger extensions, tunnels, again, more stuff that's going to show up on the thermal images. We start looking at those patterns, it's going to kind of tell me, did I have enough auger extension? So this is more I'll call it the post-mortem stuff, but we can look at a job after and see some of these big thermal differences and go, well, maybe it was something we could have or should have done differently as far as auger extensions, tunnel extensions. So wireless data near real time. so much information from the intelligent compaction and the thermal part of it. What information is going to help me? And I always like to emphasize that because there's so much information here. And I know, and you know, most of us, if not all of us, don't have time to go through all that, do all these correlations and all that type of stuff. So I'm going to go back to the fact that I believe the real time is the most valuable part of it, and even the near real time. So on the bottom right, the guys were sitting in a job shack and got Vision Link up there so we can see roller passes, and now we would be able to see thermal data on there. As a project engineer, project manager in the field even, I'd still be able to see that within minutes after it actually happened. If I caught any, anything catches my eye that looks like, hey, something we need to work on here, we can do it in real time. But a lot of information. We've got to figure out what's going to help me, and just to kind of help us sort through that. Start out with the low-hanging fruit and figure out those problems, and then get into the more detailed type of stuff. So integrating technologies for quality. Got intelligent compaction, got thermal data, and we've now also got GPR, or ground penetrating radar. And this slide, I'll thank Bryce Worry with Worry Consulting out of Bismarck. He's been doing some excellent work bringing all of these technologies together to improve quality on jobs, on paving jobs. So I know Bryce will be talking at this conference, so I'm not going to steal his thunder, but he's been doing an absolutely excellent job of bringing all these things together and really making value out of them in terms of improving quality. And the last thing I'm just going to mention quickly is e-ticketing. So we've heard a lot, seen a lot about that. That also brings in the trucking part, right? Our truck cycles from the plant to the paver, back to the plant. Again, mobile versions, real time. We've got the office part where we can look at it near real time. Another piece of information we can bring in with the IC, the thermal, the GPR, to make those real-time information decisions. So that's what I wanted to cover today. I'd like to say thank you for your attention, and there's my contact information. If anybody has any follow-up or further questions, I would be more than happy to answer those. If you're a techie, you can hold your phone up to the QR code and it should record my contact info there up to the left of my name. And then in the top right, I'll put in a little shameless plug for the Cap Paving YouTube channel that has a lot of good training stuff and setup on the paver and the rollers and some intelligent compaction stuff and some thermal stuff on there. So thank you again for attending, and thanks for your attention. Take care. Bye now.
Wow, what another great presentation. Thank you so much, Todd. All right, guys, I tell you what, we went over a little bit our morning conference time, but that's okay. So we're going to have lunch right now, and we're going to go till 2 o'clock is when our afternoon session starts. The moderator is going to be Carrie Burke, so she's going to start you up this afternoon. But I just want to say this morning, thanks a lot, and what a home run that we have just hit this morning for this asphalt convention. To start with, having the director Bill Panos, and then going to Dale Heglund, and then talk about the RAP, and talk about the UND projects that they worked on, and then to finish with Todd. I don't know if you can get, that many great presentations tied up into one conference, let alone have it in one morning. And I know this afternoon and tomorrow is going to be just as well as this morning. So once again, you guys have a great, great, great lunch. I was proud to be the moderator this morning, and hopefully we'll catch you soon, and keep in touch and have a great lunch. Thanks to our sponsors once again. You see them on the table right there that Dustin been so professionally putting them on front of the screen there. So thanks again. Enjoy your lunch, and we'll see you this afternoon.